we have so we'll start with the properties of S parameters. So last class we have been discussing on properties of S parameter, and we have discussed first and second property almost, and we'll continue from the starting, and we'll proceed with all the four properties. And please mark it as very important for your internals as well as university question paper. It's a very important question, and you can see that it is a well repeated question in most of the question papers. So they ask you the properties of S parameter and explain, or they may go for explain any two properties of S parameter, anything of that kind. So it's, or they may specify that explain the unitary property of S parameter, like that. So you have to read the question and answer to that. It carries almost 7 to 8 marks. It is easy to for you to just take those 8 marks, because it is all very simple things to understand and do it. Okay. So microwave, we have been discussing on the properties of S parameter. All of you are able to see this document, right?
Yes, sir.
Yes, sir.
Yeah. So we will continue further. We have discussed that in the previous class. The first property is zero diagonal elements. We have already discussed those things in the previous class. You know that wherever the diagonal elements are there, it is taken to be zero. So S, you know that all the diagonal elements will be S11, S22, S33, S44, etc. So here, what the first property says this: when you have an n-port network in with match termination, you have SII is equal to 0. That is what we have studied in the previous class to go ahead with. So we have understood that for the property of S parameter, the first property is zero diagonal elements, and you have seen that SII is equal to 0. So all of you have completed that. We were just started the second property as well. So the second property is symmetry of S parameter for reciprocal network. So symmetry for Z and Y parameters, Zij is equal to Zji and Yij is equal to Yji. So its symmetric property is very simple, that if you stand in front of a mirror, you can see the replica of that. So in the matrix also the same thing. So if you take S21, it should be equal to S12. So in general, you can say that Sij is equal to Sji, where I is not equal to j is very important condition that you have to follow. And so we can also say that transpose of that matrix is also matrix S. So S transpose is equal to S. So we are going to define and simplify it further. So first we are going to say that V can be written as a combination of Z and I. So matrix V is equal to matrix Z into matrix I. So before I have already discussed with you that anything which is being carried out in microwave devices, we basically go ahead with this one. So we have to just see that how uh, we are going to see all these things. We have seen that the matrix representation for uh, we are going to go everything with matrix representation. So we have in S parameters, we can write V is combination of Z and I, as you can see here. And now we are going to define this V as well as define this I in terms of A and B matrices. So as you know that the combination of V and I, you have matrix A and matrix B. So how you can write for V? V you can write it as matrix A plus matrix B. So here it is matrix A plus matrix B for V, and for I it is matrix A minus matrix B. So since you are going to take the incident and reflected waves, so I am going to just, you can note down there separately that matrix I is equal to matrix A minus matrix B, and matrix B is equal to uh, matrix A plus matrix B. So just I have taken those things here. When I move on further, So when I move on further, so I am going to just use the unitary matrix. So you can just note down that matrix V is equal to matrix A into matrix B, sorry, matrix A plus matrix B, and matrix I is equal to matrix A minus matrix B. So then you just substitute these things here, you get this second equation, that is matrix Z into matrix A minus matrix B is equal to uh, matrix A plus matrix B. So now we will just multiply that matrix Z into matrix A minus matrix Z into matrix B is equal to this portion. Take the A terms together and B terms together. So I have taken the B terms this side and A terms this side. So you know that the unity matrix U is called as the unity matrix. So you have to use that unity matrix. So you'll get Z plus matrix U into B is equal to Z minus matrix U into A. See, all of you got this equation till here. It's just simplification. All of you have completed till there.
Yes, sir.
Yeah, so what you have to do is you multiply that and take the B terms to one side and A terms to another side. U is the unitary matrix. Most of you, every one of you know that U stands for unitary matrix. So you will get matrix Z plus matrix U is equal to into matrix B is equal to matrix Z minus matrix U into matrix A. So till here, no doubts for you. So we'll proceed further. So all of you have completed till here, then we'll move to the next step.
Yes, sir.
Okay. So, so as I have informed you, you can write there U is the unitary matrix, unit matrix, and this equation we have already studied for matrix B for S parameters, or matrix S parameters can be represented as combination of matrix B and matrix A. That is, matrix B is equal to matrix S into matrix A. You can just see that we studied here this 2 pages behind where you have seen the general equations, and we have defined that matrix B is combination of matrix S into matrix A. So that equation I am going to use there. Matrix B is equal to matrix S into matrix A. So what you will get from the equation, you can just put this as equation number some equation number 1 you can put. So you can put it as equation number 1, then you can just take B is equal to, you write this as equation number 1. So if you put this as equation number 1, so you can see that B is equal to what you will get. See, B is equal to, you will get Z plus U. We get from 1 you can write from equation 1, B is equal to Z plus U inverse into Z minus U into A you will get. So you will get that. So all of you got that one? So all of you got this equation? Have you completed this equation? B is equal to this, you can get it
Yes, sir.
from equation 1. So once you complete this, then write down, so comparing both the equations. So what you can do is you can compare both the equations, this equation as well as, so you can put it as equation number 2 and this as equation number 3. So what you can do is 2 and 3 you can compare. So both are in B. So you can compare that, comparing both equations, what you can see, matrix S can be written as this much. This is matrix S. I don't get confused so much of lines. So what you can see here, matrix S, you can see from these two equations, what you can get here, matrix S is, see here, both are B, and here both it is A, and here also A. So what you can write, matrix S is equal to this much portion. So by comparing, you can write that matrix S is equal to Z plus U inverse into Z minus U. All of you got that? So here what you can write, this is R, and so this can be written as R and this can be written as Q. So this section you can write it as R. This section is R and this section is Q. Sorry, this Z minus U, you can take it as matrix R, and Z plus U, you can take it as Q, matrix Q. So I have just represented the matrix S is combination of matrix Q and matrix R. So Z minus U I have taken as matrix R, and Z plus Q I have Z plus U I have taken as matrix Q. So what I will get, matrix S is equal to the combination of Q and R. I can replace it, Q inverse matrix R I will get. So just for the simplification, I have substituted Z minus U as R and Z plus U as Q. Any doubts still here? It's not difficult for you to understand. Till here it is clear for all of you?
Yes, sir.
Okay. So
Yes,
let
sir.
us now make use of this R and Q, and just use the matrix properties and then simplify it further, and we will understand it further now. So now what you know that for reciprocity network, the matrix Z is symmetric. So what you can write is R and Q is there. You know in matrix you have the representation that if the matrix is symmetric to each other, then you can put in this way: matrix R multiplied by matrix Q is same as matrix Q into matrix R. This is matrix property. I have not used anything of microwave here. So R into Q can also be written as Q into R. So what I am going to do next step is I am just going to multiply both sides by Q inverse. Q inverse both sides. So I am going to multiply both sides with Q inverse. You can see that I have put Q inverse R Q inverse, Q inverse Q R Q inverse. So what you will get? So Q inverse, what you will get from that? You will get here Q inverse R. You will end up with this much Q inverse R, and here also you will end up with R Q inverse. So you can write it in this form, that is Q inverse R is equal to R Q inverse. So what is that? Q inverse R is same as matrix S. So it is Q inverse R is equal to S, that is equal to R Q inverse. See, I have already written here. This is Q and this is R. So that's what you are going to get. So after that, proceeding further, you will end up with this equation, that is Q inverse R is same as S, and that is same as R Q inverse. From where you got S? Here in the above equation, in this you got, it is replaced by Z plus U is replaced by Q, and so it is Q inverse R. So that's why we can write it as Q inverse R is equal to S, and that is same as RQ inverse. So till here there should not be any doubt for you. So then transpose of S is, if you take the transpose of S, so you can write it as S transpose is equal to the same equation I am using here, the same one, this one. This one I am using this matrix. If I take transpose of this, you can write it as Z minus matrix Z minus matrix U transpose into matrix Z plus matrix U transpose inverse. So I have just put transpose for all the matrices, and what you can just proceed further, since Z matrix is symmetrical, then what you can say is matrix Z minus matrix U transpose is equal to Z minus U. So this is property of matrix, that if the matrix is symmetric to each other, then its transpose is also same as the matrix itself. So Z minus U transpose can be written as Z minus U, and Z plus U transpose can also be written as Z plus U. So I am just going to replace these things further in my equation. So you can just write down substituting it further. So in this equation, so I am going to substitute the things in this equation. So what I am going to get, S transpose is equal to Z minus U into Z plus U inverse. So what is Z minus U? We have defined Z minus U. What is Z minus U? What is matrix Z minus matrix U? So what is Z minus U? Matrix Z minus matrix U. You can write it as R. So and what is Z plus U? You can write it as Q. So it can also be written as matrix Z S is equal matrix S transpose is same as matrix R Q inverse, and that is all same as matrix S. So from this, what you can understand here is the transpose of the matrix is same as the matrix S itself. So for the symmetrical junction. So this is what it talks about the property 2. So is that clear for you? See, I will just go back. I think you might have not written some of the steps. Have you completed till here?
Yes, sir.
Okay. Any doubts are there here? So what you have done here is you have used the properties of matrix to simplify it, and you have substituted and shown that transpose of S is same as S itself. So since it is using all these properties of S matrix, and you know that the matrix properties you have already studied in mathematics, so all those properties you have to use it here. Like you have used Q inverse on both sides, it's not going to create any difference for the change in equation, but when Q inverse you will put on both sides, you will further simplify it as Q inverse into matrix R is equal to S into matrix R into Q inverse. So that is what you will end up with, and finally you will get matrix S is equal to or S transpose is same as matrix S. You have any doubts in this one? Bhumika, it's clear?
Yes.
Okay. So anyone is having any doubts? We'll move on to the third property. Shall we move on to the third property?
Yes, sir.
Okay. So just I will brief this second once again, and then we will move on to the third property. So just to concentrate here, we have a symmetric property, and we are going to say that transpose of S is same as S. We have taken V is equal to Z into I, and Z we have just simplified further. V and I can be represented in terms of A and B, that you know that incident and reflection coefficients A and B. So V can be defined as matrix A plus matrix B, and I can be defined as matrix A minus matrix B. So by using the multiplication, we have simplified further, and we separated the A terms and B terms for either side. So we got Z minus Z plus U into matrix B is equal to Z minus U into matrix A. Just concentrate here. So after that, we have this equation for matrix B, that is matrix S into matrix A. We also got the equation for matrix B from equation 1, that is matrix Z plus matrix U inverse is equal to matrix Z minus matrix U into A. So we understood that this can be this one, S can be this. So we have just replaced matrix S as, by comparing these two equations, we have replaced S as Z plus U inverse into Z minus U. So for simplification, it is easy to simplify. So we have just substituted the terms for Z plus U as Q and Z minus U as R for the simplification purpose. So from reciprocal network, the matrix Z is symmetric. So what you can write is you got here R and Q for Z minus U and Z plus U. So since it is symmetric, you can write as R matrix Q is same as matrix Q into matrix R. Further to simplify, I have just multiplied Q inverse on both sides, Q inverse matrix on both sides, in both right and left hand side. So what I got here further, Q inverse will be simplified in both places. So left out will be Q inverse R is same as R Q inverse, and you have already defined that Q inverse R is, so Q inverse R is S. So it is already understood that Q inverse R is S. So I have just substituted that in place of Q inverse R as S. So Q inverse R is same as S, and that is also equal to R Q inverse. Now I went with the transpose property, and I just defined the matrix S which we have before. So the entire I have taken transpose of that. S transpose is equal to this matrix transpose, and this also matrix transpose, which we have studied before here. This one, this equation, same equation. I took the transpose of that. So when I took the transpose of that, I found that Z minus U transpose is same as Z minus U when the matrix is symmetrical. So similarly, Z plus U transpose is same as Z plus U when it is symmetrical. So I replaced both the transpose by this matrices Z minus U and Z plus U. So I ended up with this equation, that is S transpose is Z minus U into Z plus U inverse. So I have Z minus U and Z plus U defined before in terms of R and Q. So R is Z minus U and Q is Z plus U. So I replace R and Q further in the equation. So I got S transpose is equal to RQ inverse. And since we know that RQ inverse is S, so S transpose is same as S. So this is what you will get for a symmetrical junction. So that is the second property. I think it's clear for all of you. Is that clear for all of you?
Yes.
Okay.
Yes, sir.
So yeah, fine. So we will move on to the third property. You just write down this. I'll explain it for you. So third property is unitary property for a lossless junction. So here we will be using some sigma properties and all those things. So just note down these things. We will explain it detail. So just note down unitary property for a lossless junction. That is third property. So for this, for a lossless network, sum of the products of each term at any one row or any one column of S matrix with its complex conjugate is unity. This you should understand. And for lossless N-port device, the total power leaving the N-port must be equal to the total power input to the input. So we'll see that those things. So just write down these 2 points, and we will explain it and then move on with the equations. So I have given you notes till here, I hope so. Correct? This also I have given?
No, sir. Till second.
No, sir.
Till previous I have given, I think. Okay, this I will send it to
Second
you.
start.
Okay. I'll continue that. I'll give further. You can, if you missed out anywhere here and there, you can just complete it. So study all these topics. 1.5 module will be there. These all things will be there for your internals. So study all these topics. So your internals is on 24th. So all of you know that, I hope so. Before that, I have put the deadline for assignment, that is on 21st. So all of you should complete the assignment questions before internals and submit it in the MS Teams. So this time we will not be sending any Google form and all. So get used to your MS Teams properly and inform your friends that if they are not having this MS Team mail ID and all those things, please contact your class teacher. Make sure that you should have your mail IDs properly working. Otherwise, it will become difficult for you. So just inform your friends regarding that. And if you have any problems, feel free to contact your class teacher regarding MS Teams, and so that they can help you out. So don't keep everything at the first day of internals. Okay. So if you have completed writing it up, I will start with the explanation. You complete it off, we'll then start with the explanation. Unitary property for lossless junction. So if you have completed, shall we go ahead with further?
Yes, sir.
Okay. So anyhow, I'll send you this, but in the class itself, you try to complete it. It is easy for you. No need to spend more time for this further. You can just go through it, and if you have left out anything, you can complete it further. So we have been discussing property 1 and property 2, and now we are going to see with the third property, that is unitary property for a lossless junction. This is called as a unitary property. So you can just underline this unitary property for a lossless junction. So you know that you are taking any network. I have defined that any network you take, it will have 2 ports. The minimum is 2 ports, and you may have multiple ports as well. Some you may have 5 to 6 input ports and some output ports and all those things. So you are just defining that there are n port network. So you are having many ports, and in that we are going to see that it is having a lossless junction, and now we are going to see how these things works out for us. For a lossless network, the sum of the products of each term of any row or column of a S matrix. You take if you are taking a lossless network, the product of any of the rows or any of the column of S matrix with its complex conjugate has to be unity. So that is very important. So you have to go, if you take the product of each term of one row and any one column in the S matrix, it's with its complex conjugate, it should be unity. Okay, so what do you mean by complex conjugate and all? You know that, which you have studied in mathematics before, conjugate and all those things. So that is one thing what you have to understand. For a lossless network, the sum of the products of one row or any column in a S matrix, if the with its conjugate is unity. So we are going to use this. Okay, this thing is called as the unitary property. So this statement is must in your internals or externals. And further, moving on to that, for lossless N-port device, the total power leaving. So if you take one signal, so you have this one. So this is like a two-port network. So you can see that you have two ports here. This portion is one port, and this portion is another port. So this will be called as two port. So this is called as two port network, and where you can have two ports here. You can have multiple ports also as per your requirement. So that is one thing you can understand here. For a lossless N port device, the total power leaving N port must be equal to the total power input to these ports. So then we can define this in this form. So this is what we can say. Input power is same as the total power. So that is what you are going to get. The total power leaving. So how much power is leaving out from the port is same as the total power input to the port. So we can write it in the form of summation, sum of n to 1 to n. So it is the number of ports. Small n is 1 to n. It indicates the number of ports. That is summation of bn square is equal to n is equal to 1 to n summation of an square. So we are taking that input power is same as the output power. So that is what we defined, summation of this is equal to summation of this. We already defined that B is equal to matrix S into matrix A. This equation is known to us. So if you have completed this portion, we will just continue further. Is it over?
Yes, sir.
Yes, sir.
Okay. So these two equations you just understand. We are going to use it further. So what you understood from the previous thing, you found that matrix B can be represented as combination of S into A. So I am going to replace this B as combination of S and A. So I can see, you can see here. So I replace that B as combination of S and A. Here you can see. Here you can see this portion. You can see I have replaced B as combination of S and A. So summation of n is equal to 1 to n, and summation of I is equal to 1 to n. Sni ai modulus of that square is equal to the same thing, whatever we have written before. Summation of n is equal to 1 to n an square. So here one thing what you have to understand here is the ith port is excited and other ports are matched. An is equal to 0. So we are only bothered about the ith port, and we are taking all other ports to be 0. So what except AI, all other ports we are not worried about. So when we are only worried about the ith port and we are considering other ports to be 0, just you can say that this summation is not having much meaning now, because you can just replace this summation as only in terms of ith term. So it is Sni SAI. And this also I am not worried about AN, I am only worried about ith term. So I have written AI. So summation of n is equal to 1 to n. This summation is not required because all my terms are considered to be 0 except the ith port. So I have eliminated that. I wrote only in I. So SNI AI modulus square is equal to summation of n is equal to 1 to n AI square. Summation can be redefined in this form. So I have just split those things. Summation of n is equal to 1 to n SNI square, summation of 1 to n ANI AI square, that is equal to the same thing. Is there any doubt till here, this portion? Is there any doubt till here? So I have taken only the ith port is excited. Rest of the ports I have taken to be 0 because other ports are matched and we considered AN is equal to 0. Any doubt till here, this point? Is that clear for you?
Yes,
Tell
sir.
some. Yeah, fine. So we will just go ahead further. So here you can see that summation of n is equal to 1 to n a I square and summation of n to 1 is 1 to n a I square. Can you just remove these things off? So what you'll get summation of n is equal to 1 to n S n I square is equal to 1. So this you have studied in mathematics that modulus of ni square can also be written as an SNI conjugate. So this is from the mathematics. So what you can write, the summation of SNI mode of SNI square can also be written as SNI conjugate. So that is taken from mathematics. So we have to use that. So what we will get, summation of n is equal to 1 to n SNI square will come as 1 because these two terms are same. So SNI square will be equal to 1 and that is also written as SNI n is equal to 1 to n SNI conjugate. So this mode of ni square can be written as SNI conjugate. So what you will get, so I have just written this much portion. So this portion I have written further. So you can see that for lossless junction, summation of n is equal to 1 to capital N, yes, SNI conjugate is equal to 1. The same thing I have written it once again. So first you complete it till here, then we will move on further. Is that clear till here? This equation, till this equation, is that clear for you? See for
Yes, sir.
okay, fine. So complete it till there, and then we will continue further. If you have completed, just let me know that, then we'll move further. So it's all quite easy, and you find it very interesting to, once you study, you can do it for the examinations. You have to just write as it is. They will ask straightforward questions that explain the properties of S parameters, and they don't go for any deviations in the question. So it will be quite easy for you to write if you study once. If you have completed, just I'll continue that further.
Completed, sir.
Yeah. So you got till here for a lossless junction. So you got till here for a lossless junction. You got summation of n is equal to 1 to n. SNI conjugate is 1. So we are just going further. If all an is equal to 0 except that 2 we are taking, that is ai and ak, and we are going for the condition that I is not equal to k, means two things we are taking, I and k. If all an is equal to 0, we got this for all an is equal to except I. Now we are going for if all an is equal to 0 except ai and ak. So 2 we are taking ai and ak. So I should not be equal to k. Then the equation will be modified in this form that n is equal to 1 to n snk sni conjugate. So you can see that here it will be written as I will be getting replaced as k. So you have to write n is equal to 1 to n snk sna conjugate is equal to 0. It will become 0 when I is not equal to k. So summation of that will be equal to 0. So these are the two equations for lossless junction. When you have I put, you have n is equal to 1 to n, sna conjugate will be equal to 1. And when you have I not equal to k, you can get n is equal to 1 to n, snk sni conjugate is equal to 0. So let us in matrix we know that conjugate of the matrix multiplied by the matrix is same as a unitary matrix. This is the matrix property. So we know that in matrix S conjugate multiplied by S is equal to unitary matrix. We have already defined in the previous property that transpose is same as matrix S. In the second property we have defined that matrix S is equal to its transpose. So why can't we just replace the matrix S by its transpose? So we have just replaced the redefine this and write it as S conjugate multiplied by S transpose is equal to U. And if you just simplify it further, you can write it as S conjugate is same as the transpose inverse. So in matrix which satisfies the condition is called as the unitary matrix. The matrix which will satisfy this condition, that is S conjugate is equal to transpose of inverse of that inverse transpose, then we call that as the unitary matrix. And here two equations you are very much important here, this equation and this equation. These two equations are important where you have n is equal to 1 to n sna conjugate is equal to 1, and n is equal to 1 to n snk conjugate is equal to 0, and s conjugate is equal to s transpose inverse, and this condition satisfied, then it is called as unitary matrix. You complete it off. I think we have not done anything too much difficult here. It will be clear for you. Any doubts are there? Is there any doubts for you? We have just used the matrix and substituted S is equal to S transpose in that and simplified it. Is that clear for all of you?
Yes, sir.
Okay. So since it is important, I will just go once more in third property in brief, and once you complete the write-up. Is that over?
Yeah, sir.
Okay. So just listen here. Don't write anything for time being. Just listen here. This is for you to just understand it once again. Unitary property basically deals with this. This is very important for a lossless network. The sum of the product of one row and or any one column of a S matrix is with its complex conjugate is unity. So also we have written with the help of we are taking the n port network, and we wrote summation of n is equal to 1 to n bn square is equal to summation of 1 to n mod an square, and we know that B is same as matrix S into matrix A. So now we are substituting in place of B in the previous equation as S and A. So we wrote it in general as I is equal to 1 to n sni ai whole square. So this we have done for many ports. So we will define that only ith port exists and all other ports in the matched network are considered to be 0. So when you are expecting only the ith port, it will be all converted to I. So we have written that n is equal to 1 to n Sni ai whole square is equal to n is equal to 1 to n ai square. N will become I. So you can split the summation. I have split the summation, and when you split summation of n is equal to 1 to n ai is square is there both sides. So you can write it as summation of n is equal to 1 to n n sni square is equal to 1. So in mathematics, you should have studied that modulus of a Sni square can also be written as Sni conjugate. So I have just used that and wrote it here. So summation of n is equal to 1 to n Sni conjugate is equal to 1 is for the lossless junction. So if all an is equal to 0 except I, ai and ak, we are taking two terms I and k. I not equal to k, then if you take the conjugate of that n is equal to 1 to n snk sni conjugate, then it should be equal to 0. So these two equations we have, and we are using the previous property 2, and we are simplifying it further. So in property 2, you have studied that S transpose is same as S. So we also know that in by using the matrix property, conjugate of a matrix multiplied by its matrix itself is a unitary matrix. So S conjugate into S is equal to U, and you substitute the property 2 in this. So you have matrix S can be replaced as S transpose. So I have written that S conjugate S transpose is equal to U, and finally when I simplify it, I can also write it as S conjugate is equal to S transpose inverse. So which satisfy the condition for the matrix which satisfy the condition is called as the unitary matrix. So this is what about unitary matrix. The fourth property is very simple. All of you have completed the unitary property, correct? Is there any doubt? It's clear for all of you?
Yeah, sir.
So write down the fourth property, phase shift property. So phase shift is quite simple one. The S parameters with respect to position of port or reference plane. So we are just shifting the reference plane. Like you are running in 100-meter speed. You have some water in between. You have some sand in between. So your speed, and even though you are running in the speed, your speed will vary in that places. So that is what you're shifting the reference plane here. So when you shift the reference plane, the phase also will have a shift in it. So that is what is going to happen here. So you can see the phase shift property, we have taken this as 1 and we have shifted it as 1 dash, and you can see it is 2 and we have shifted it as 2 dash. So you can just write down. There is no further much to understand in that. We will just explain it with metrics. What will happen with the phase shift? So the phase shift property, the S parameter with respect to the position of the port or reference plane is. So you can see 1 is shifted to 1 dash and 2 is shifted to 2 dash. So matrix S is as usual S11, S12, S21 and S22. So when there is a shift in the phase, the electrical phase shift like phi 1 and phi 2 will come into existence, and we'll see that. Just as of now, you write down this. We'll continue with this property 4 in the next class in much detail. So you can just note down these things as of now. So if you have any doubts further, we'll discuss. Okay, it's clear, no? Property 1, 2, 3, and 4 we'll discuss further. It's clear for all of you. See, is that clear for all of you?
Yes, sir.
Yes, sir.
Okay. So we will stop for today, and we'll continue in the next class. Okay.